Hi, this is lesson 1.5 in geometry, and in this lesson we're going to be talking about special angle pairs and how we can use those to find angle measures. Now the first angle pair that we're going to talk about is called adjacent angles. Okay, adjacent angles. And that refers to two coplanar angles, so two angles that are in the same plane with a common side. So here you have angle 1 and here you have angle 2. And they share a common side right here. This is the common side. And they have a common vertex. So here's the vertex of angle 1, and here's the vertex of angle 2. It's the same point. And they have no common interior points. In other words, they don't overlap at all. So if you have a point here in angle 1 in the interior, that point is not located at all in angle 2, or any of those points are not located in angle 2. So they don't overlap. Here's another example. Angle 3 and angle 4 are called adjacent angles because they have a common side, they share a common vertex, and the two angles don't overlap. Now, I just want to remind you about what the word adjacent means. So let's talk about my neighborhood right here. So here's my property line, and then this is where my neighbors, where their area is. And so I would say that because we share this line right here, a property line, that we are adjacent to one another. So adjacent means right next to each other, okay? So adjacent means right next to each other. The next type of angle pair we're going to talk about is vertical angles. Vertical angles are two angles whose sides are opposite rays. So angle 1 right here and angle 2 are vertical angles because this side of angle 1 is an opposite ray with this side of angle 2, and this side of angle 1 is a vertical ray with this side of angle 2. So these two are called vertical angles, angle 1 and angle 2. It's a vertical angle pair. And angle 3 and angle 4 are a vertical angle pair. So they're right across each other. So if you make basically an X with two lines, the angles across from each other are called vertical angles. And you can also think of it this way. They make, basically, I think of it as two V's put together. Actually, you have four V's right here. Okay, a bunch of little V's. So vertical angles. So they're right across from each other. Complementary angles. Those are two angles whose measures have a sum of 90 degrees. So if you add the two angles together, they add up to 90 degrees. Each angle is called a complement of the other. So here we have some examples. Now this little box right here, that tells us that we have a right angle, which means it's 90 degrees, and we'll be talking more about that later. But if you add angle 1 with angle 2 using the angle addition postulate, they would add up to 90, which means that angle 1 and angle 2 are complementary. Now, another word that we could use to describe angles 1 and 2 would be that they are adjacent because they share the same vertex and they have a common side. So they are adjacent complementary angles. Here, angle A and angle B, angle A is 47 degrees, angle B is 43. If you add 47 to 43, that equals 90 degrees. So we would say angle A and angle B are complementary also. And in this figure I have over here, we have squares and little squares in the corner, which mean that these are all right angles. So this is a rectangle. Angle 1 and angle 2 add up to 90, so they're complementary. Angle 3 and angle 4 are complementary because they add up to 90. Angle 5 and angle 6 add up to 90, and angle 8 and angle 7 add up to 90, so they are complementary. Supplementary is when two angles who have the measure that have the sum of the measures of 180 degrees. Each angle is called a supplement of the other. So in this case, we have angle 3 and angle 4. And again, angle 3 and 4 in this case are adjacent angles because they share a side and a common vertex and no common interior points. But we know that this is a straight line, a straight angle. And so this is 180 degrees. So if you add angle 4 and angle 3 together, they add up to 180, so we say they're supplementary. And then angle C and D here, these are not adjacent, but 137 plus 43 equals 180, which means these are also supplementary. So just to recap, complementary angles are, they have a sum of 90 degrees. Supplementary angles have a sum of 180. And you have to memorize these terms. You're going to see these over and over again, and you're going to need to use these terms to solve problems. Sometimes I like to come up with little tricks for remembering things. I'm very visual, so I like to, I look at the words complementary and supplementary, and I say, well, if I was alphabetizing them, C comes before S in the alphabet. So this is alphabetical order. If I was putting the numbers in order, 90 comes before 180 when you're counting. So complementary is like a smaller, comes earlier in the alphabet, 90 comes earlier when you're counting. Supplementary comes later in the alphabet, 180 comes later when you're counting. So somehow, some kind of trick you need to use so that you can have that memorized. Next one says, use the diagram at the right. Is the statement true? Explain. So angle BFD and angle CFD are adjacent angles. We have to decide if it's true. So angle BFD, so from B to F to D, that's angle BFD, and angle CFD, so from C to F to D. Okay, are they adjacent? Well, no, they actually overlap. Angle CFD is kind of inside. And so remember, if they're adjacent, they don't have any common interior points. Well, if you pick a point right here that is inside of angle CFD, that point is also inside of angle BFD. So that would be false. They are not adjacent. All right, the next one says angle AFB. So AFB is this one, and angle EFD is this one. It says they are vertical angles. All right, so remember vertical angles, if you look at the sides, it's like you can make an X with the sides. Well, this line is not, this line is not the side. This side is not the side of this one over here. Okay, this would go like this if we kind of made a straight line. So this would be false also. I'm going to try to erase this. My board is not cooperating just lately when I'm trying to use the eraser. Okay, next one says angle AFE and angle BFC are complementary. Well, again, think about what does complementary mean? It means the sum is equal to 90. So 62 plus 28, what does that equal? 90, so that would be true because their sum is equal to 90. All right, something else you need to understand in geometry is there are things that you can conclude when you look at a diagram that you can assume, and there are things that you cannot assume when you look at the diagram. Let's start with the first one. Points are coplanar. So when you look at this diagram, points A, B, C, D, E, they're all on the same plane. Okay, there's nothing three-dimensional about this figure, so assume they're all coplanar. You can assume that angles are adjacent when they share a side. So like angle EBC is adjacent to angle EBD. Or you also know then that angle EBD, this one right here, is adjacent to angle DBA because they share a side. You can assume if angles look adjacent and if they look supplementary that they are, and you can assume that if angles look like they're made by two lines crossing, they're vertical angles. So these two are vertical angles, and this one are vertical angles. And also, it says collinear points and a point of intersection. So we can assume that points A, B, and C, they look like they're on the line. You can assume, yes, they are on the line. B isn't slightly off. If it looks like it's there, it's on the line. And you can assume that ray BD, and if you look at ray BE, they intersect at point B. You can assume that. Now, things that you cannot conclude from a diagram. You cannot conclude, or you cannot assume, that angles or segments are congruent. Now, in this figure right here, it looks like angle DBE and angle EBC, they look pretty close to the same, but we can't assume it unless they were marked. Like if you had two ticks here and two ticks here, you would know then that they are congruent, which means they're the same measure. But they have to have the marking. If they did not have that marking, you could not assume it. And you cannot conclude or assume that you have a right angle. Angle DBA looks like it's 90 degrees, but it could be 89.9. So unless you're told that it's a right angle, or that the measure is equal to 90, or that it has this symbol right here, the little box, you cannot conclude it just from looking at it. And also, you can't assume that angles are complementary. So can't assume that they're complementary all the time if they look like it. In this case, it looks like angle DBC is a right angle, but again, if there was no marking, we wouldn't know that. So then you can't assume that these two are 90 degrees. So like in this picture right here, it looks like this plus this equals 90. However, you don't know that this is a 90-degree angle right here. However, if you had a little box there, then you could say these two are complementary. So let's look at an example here. It says, what can you conclude from the information in the diagram? So there are a lot of things going on here. First of all, I see these little tick marks right here. Well, that tells me that the measure of angle 1 equals the measure of angle 2. Okay, they're the same measure. What else can I conclude? Well, let's see. Angle 3 is right here. And angle 5, if I extend this line, and if I extend this line, I get angle 5 over here. Angle 3 and angle 5 are vertical angles. Okay. And then I also can conclude that, let's see, angle 4 and 5, these two right here are supplementary. And I can conclude that angle 3 and 4 are supplementary. Okay, they're adjacent. I can conclude that angle 1 and 2 are adjacent, angle 2 and 3 are adjacent, angle 3 and 4 are adjacent, and angle 4 and 5, and angle 5 and 1 are adjacent. So those are the conclusions that I can make. All right, next problem. Can you make each conclusion from the information in the diagram? So let's look at this diagram. We have line segment PQ, line segment TV, and it says that segment TW, which is this one, is congruent to line segment VWV. Well, we have the little tick marks, and remember that means that this length is equal to this length, and so if the lengths are the same, then the segments are congruent. So yes, we can put the reason would be equal lengths. Next, it says that segment PW is congruent to segment WQ. Now we're talking about this and this. Well, there are no marks. It looks like they're congruent, but again, if we don't have the marks, we cannot assume that. Here's the thing. This could be 3.9 inches, and this could be 3.8 inches if this was moved over just a hair or whatever. So this would be a no, because there are no tick marks or numbers, numerical values. The next one says, can you assume that angle TWQ, that's this right here, is a right angle? And again, no, because there's no numbers, no symbol, or no measures or symbols. And if it was a right angle, remember to have the little square in the bottom. And then the next one says that segment TV, so TV bisects segment PQ. All right, so here's where we have to understand here. Remember, bisect means cuts in half. And so when you do a problem like this, because a lot of times students will mix up which one is bisecting which, substitute the words in cuts in half. So segment TV cuts in half PQ. Well, do we know that PQ is in half? No. So this would be false. It should be the other way around. This segment is going through the midpoint, and we know it's the midpoint because these two sides, or these two segments, are equal in length, and so this is bisecting this one. So it should be the other way around. PQ, segment PQ, bisects segment TV, because TV is the one that gets cut in half. Segment TV. All right, so let's move on. Another vocabulary term for you is linear pair, and that is a pair of adjacent angles. So we have two angles here, and they're adjacent because they have a common side, common vertex. They're not overlapping, and they're sides that are not common. So this is the common side. So this side here and this side here, so these are the uncommon sides of the two angles, they form opposite rays. The angles of a linear pair form a straight angle. So if you add this angle to this angle, you have 180 degrees. So going all the way around, that's 180 degrees. And so the two angles, when they're put together, form a straight angle. It's called a linear pair. Catch that the word line is in that term, linear pair. So two of the sides form a line. All right, and now we have a postulate about a linear pair. So if you have a linear pair, so if two angles form a linear pair, then they are supplementary. Because if the two angles form a line, which is 180 degrees, that means the two angles add up to 180. So that is an accepted fact. It's a postulate. So they are supplementary. All right, so let's do a problem where we have to apply what we've just learned. It says angle KPL and angle JPL are a linear pair. It gives us the measures of each. What are the measures of the angles? Now remember I said it's always good to draw a picture. This one we actually wouldn't need to, but it says they're a linear pair, so I'm just going to do this. So KPL, so I know P because P is in the center, P is the vertex, and JPL, whoops, where's my J? KPL, and something's wrong here. Oh, I know it's wrong. I put those in the wrong spot. So these are a little bit trickier to draw. Let me go backwards. Okay, let's go this way here. So they both share L. So that's the one I need to have right here. That is P. So then this would be KPL, and then this would be JPL. And so now I'll label KPL is 2x plus 24, and angle JPL is 4x plus 36. So 4 times x, and this is 2 times x. This one's going to be the larger angle, so actually I should have switched that around, but that's okay. It just helps us visualize exactly what's going on. What do you know about these two angles? Well, since it's a linear pair, the two of them add up to 180. So in that case, that was a little bit confusing to draw, and I really didn't even need to because it says KPL, which is this one, JPL, which is this one. Okay, it tells us what those are. If they're a linear pair, that means they add up to 180. So then we can just make an equation. So KPL is 2x plus 24. The measure of angle JPL is 4x plus 36. So we're going to add the two angles together. It will equal 180. So let's solve this. So first, combine like terms. So if we have 2x and 4x all together, you have 6x on that side, and 24 and 36. So 36, 40 plus 20 is 60. And we have 180. And we subtract 60 from both sides. divide both sides by 6. So x equals 20. And then we can, it says to find the measures of the angle, so we have to substitute 20 back in. So 2 times 20 plus 24. So 40 plus 24 is 64 degrees. And 4x plus 36. So 4 times 20 plus 36. So that's 80, 110, 116. All right. So let's just double check. 116 plus 64. Let's add those together. And we get 180 degrees. So yep, that works. Okay, another term for you, angle bisector. It is a ray that divides an angle into two congruent angles. So remember, bisect means cut in half. So if you have an angle bisector, it cuts it in half. So angle XAY is congruent to angle YAZ. So if you're told you have an angle bisector, then you know you have two congruent angles. So let's do a problem here. It says AC bisects angle DAB. If the measure of angle DAC equals 58, what is the measure of angle DAB? Now this one I will probably want to draw. So angle DAB, it's getting bisected by AC. And as soon as you read the word bisect, you know that this angle and this angle are congruent. So mark them that way on your figure. And then label. So it says angle DAC is 58. What is the measure of angle DAB? Well, DAB is the whole thing. So if this is 58, you know that this is 58, so you can fill that in. And the whole thing would be 58 plus 58, which is 116. Okay? All right, next one says, ray KM bisects angle JKL. So KM bisects. Again, I draw the picture, mark the angles congruent. Okay, what else do they tell us? If the measure of angle JKL, well, that's the whole thing, okay? The whole thing measures 72. What is the measure of angle JKM? Well, it would be half of 72. So 72 divided by 2 is 36. So your answer would be 36 degrees. All right, here's another one. It says find the value of x and y. All right, so if we look at this, we have a few different ways we could do this. Actually, I think there's probably one way to do it right now. After a day or two, you're going to learn another technique that'll work real well. But we look at this and we have x's and we have a y. We need to make an equation. And remember from Algebra 1 that we only can use one variable if we have one equation. So we need to work with this angle and with this angle because they both have x's. And so you have to think about, now what do you know about those two angles? Well, they are adjacent and also they are a linear pair, which means their sum is equal to 180. So we'll write an equation, 9x plus 20 plus 7x equals 180. So that gives us, we combine like terms, 16x plus 20 equals 180. So 16x equals 160. And if we divide both sides by 16, x equals 10. All right, now we have to find the value of y. So here's what we're going to have to do. We're going to have to substitute back in because we know that these two are a linear pair. We also know that these two are a linear pair. So if we know what this angle is, we can come up with an equation. So if we substitute 10 in here, 9 times 10 is 90 plus 20. That is 110 degrees. And what do you know about these two angles? Well, these two angles have to equal 180. So we have a couple ways that we can do this. We can make an equation that says 2y plus 110 equals 180 and solve the equation. And then if we divide by 2, y is equal to 35. Okay? Now, the other way you could do it, and basically you're doing the same thing, only you're doing some of the steps in your head. You know that if this angle's 110, this entire angle would have to be 70. So you can say that 2y equals 70 and divide both sides by 2. So y equals 35. All right, and those are your answers for that. Okay, a couple questions here. Name a pair of the following types of angle pairs. So vertical angles. So vertical angles are when we have two lines that cross. So here you have a line and here you have a line. Okay, so we have two sets of vertical angles. So this and this would be a vertical angle. So angle ACB and angle, so AC, did I say C? I said that wrong, sorry. AFC, how about that? Angle AFC, AFC, and then angle EFD. So that would be this angle pair, vertical angle pair. Another vertical angle pair would be this set, and that's angle AFE, AFE, and angle CFD. Those are vertical angles. Next, complementary angles. All right, so angle B, right here, angle ABD, which there's just one angle here, so I can call this angle B is equal to 90. That's not complementary. Those are going to be supplementary. I maybe don't have that information here. I need to erase some lines here. I don't have enough information for that one. Supplementary angles, though, would be angle B and angle E. This should say supplementary. So that's a typo. So angle B and angle E are supplementary angles because they add up to 180. Next, a linear pair. Well, a linear pair, remember, those add up to 180. And angle B and E add up to 180. However, they don't share a common side. They're not adjacent. So an example of a linear pair would be like angle AFE. Let me get a different color here. Angle AFE and angle DFE. These two, okay? Or these two, or these two, or these two, okay? So you would just write those down. Here's another problem. It says ray PB bisects angle RPT. So let's draw that angle RPT, and PB bisects it. And that tells me right away, mark those congruent, and then now label. Angle, the measure of angle RPB, this one right here is x plus 2, and the measure of angle TPB is 2x minus 6. What is the measure of angle RPT, the whole thing? Well, here again, we can't just add these together and set it equal to the total because we don't have the total. But we have to look and say, what do we know? Well, I know that this angle is equal to this angle, so we're going to set those two equal to each other, those measurements equal to each other, and then solve the equation. This one's going to give us some negatives the way I'm solving it. So this is negative 1x plus 2 equals a negative 6. And then we subtract 2. So negative 1x equals negative 6, and negative 2 would be a negative 8. And then we divide both sides by a negative 1. So x equals 8. And then what we're going to do is substitute back in. So 8 plus 2 is 10, and 2 times 8 is 16, minus 6, and that equals 10. So the measurement of angle RPT would equal 10 plus 10, which is 20 degrees. And that's it for this lesson. Let me know if you have questions. Thanks for watching.